Good morning, my dear students. Once again, we start a fresh week and we are completing November month. Therefore, we have to praise God, right? Tomorrow we are starting December. Still, we do not know what is the plan for government about their plus 2 exams this year. Maybe this week they are going to announce it. So, we are waiting for the very important announcement of government. Okay. So, as far as chemistry is concerned, 12th chemistry, we are continuing the 4th lesson about transition metals and inner transition metals. So the elements which are present, the D block elements are called as inner transition elements. They are present from group 3 to group 12. And the last electron goes into D. We already discussed about the position in the periodic table, electronic configuration, metallic property, atomic size, ionization energy, and electrode potential. These are the properties that we have already discussed, and today we are going to the next property that is called the magnetic properties. So almost all the transition metals that we have from group 3 to group 12 have paramagnetic character, right? So we should know there are 3 types of magnetic characters which we will study very detailedly in physics, right? But in a crisp way, in a very short way, we should know that what is diamagnetic, what is paramagnetic, and what is ferromagnetic, right? So diamagnetic is the one which will not attract the magnetic field. They will not experience any magnetic field and magnetic properties, and that is being called as diamagnetic. This we observe whenever all the orbitals in the atom are having paired electrons. So whenever the orbital is containing paired electrons, then they experience this diamagnetic property, because one is having clockwise, the other one is in the anti-clockwise. They don't develop dipoles, therefore they always repel with the magnetic field. Hence, their magnetic property is always 0. They don't have magnetic property also at all. That is called diamagnetic property. But what is paramagnetic property? Paramagnetic property is seen in the substances which have unpaired electrons. If they have unpaired electrons in the orbitals, definitely they have this paramagnetic character, because this develops the magnetic poles, and the magnetic poles, in the sense they have north poles and south poles, attracting magnetic field this end as well as this end. That's called magnetic poles. And these magnetic poles, if they are present in the presence of a magnetic field, if there is an external magnetic field, all these dipoles will be attracted towards north pole or towards the south pole. This type of property is called as the paramagnetic property. And ferromagnetic is the one which has got the highest magnetic property, which is mainly because of the iron substances. They also have lot of dipole magnets, and also they have unpaired electrons, right? They also have unpaired electrons in large number. They also have this dipoles, magnetic dipoles in large number. So these are the 3 magnetic properties. The strength of the magnetic field or the strength of the magnetic property is always measured using a parameter called magnetic moment. Magnetic moment is always calculated using this formula, G into root of S into S plus 1, where S is the spin quantum number. It is a spin of the electron, clockwise or anti-clockwise, which mostly decides the magnetic property of the elements. The spin may be clockwise or anti-clockwise, but the spin value depends upon the principal quantum number divided by 2. So S value is n by 2. The number of spin electrons having spin in an orbit or shell will be taken into consideration, and the principal quantum number will be divided by 2, and therefore if you rearrange, and the G value for electron is calculated to be 2, so this G becomes 2 for electron, and we have this formula rearranged to n into n plus 2. So if this 2 goes inside the root, it will become 4. Therefore 4 gets cancelled and it becomes n into n plus 2 and it is Bohr magnetron. For example, they asked simple problems like this. Calculate the magnetic moment of Mn plus 2 ion. So 2 more questions they will ask. Right? Now we know the formula mu is equal to root of n into n plus 2. So what is this? N is the number of unpaired electrons. That's what we have to find out. Right? Manganese has got the atomic number 24. Right? So 25. So its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Right? When it becomes Mn plus 2, that means these 2 electrons will not be present. And it becomes 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. Now we come to the last orbit, valency orbital, and we'll see how many unpaired electrons in it. It has got 5. 1, 2, 3, 4, 5. Therefore we find the value of n. N value is now 5 because it has got 5 unpaired electrons. Therefore magnetic moment is calculated as root of 5 into 5 plus 2. That is root of 5 into 7. That is root of 35. So root of 35, root of 36 is 6. Therefore 35 will be 5.91 Bohr magnetron. This is the unit. PM na eluduvanga, mu b na eluduvanga. So this is how you should calculate. So write the electronic configuration. From the electronic configuration, find out the electronic configuration of ion. Then in the ion, find out the number of unpaired electrons. And using the unpaired electrons, this formula should be used to calculate the magnetic moment. So under this property, we should know that all transition metals have a paramagnetic property because of the presence of the unpaired electron, right? And diamagnetic is one which has got the minimum magnetic property, and ferromagnetic property is a property which contains the maximum property, right? So this is the this is about the magnetic properties, right? So next property of this transition metal is catalytic activity. So catalysts are very important in chemistry, which make our work easy because they are helping us to complete the chemical reactions very easily, and they mainly do three things. First thing, they lower the energy and make us to complete the reaction with less energy. Then they always interact with the reactants and they help us to convert the reactants into products. These are the three major advantages of using a catalyst in any type of chemical reaction. Most of the industries, most of the reactions in the hospitals and medical field are also being used in this catalyst, right? The transition metals are always capable of acting as catalysts because they have got a very active d orbitals in which we have the electrons which are ready to involve in bonding with the reactants. So the electrons which are present in the d orbitals can interact with the reactants and make bonds, and as a result of that the reaction starts functioning and getting completed to form the product. For example, if we take the hydrogenation of ethylene, hydrogenation of an alkene, right? This is the reaction. So in the alkene we have the double bond, right? And this reacts with the nickel catalyst with hydrogen, right? Right. In this, what is the reaction that is taking place, right? The nickel has got d electrons, and these d electrons are useful in breaking the hydrogen molecule. The sigma bond first breaks, and each hydrogen gets one electron, and this, using these electrons, it will join with the nickel electrons and form a bond first with nickel. So this is the first stage. So the sigma bond of hydrogen breaks, getting each one electron. Then after that they make bond with nickel, because nickel is having the d electrons, and after that these hydrogen atoms break the bond with nickel, and they start breaking the pi electrons which are present in the double bond. So double bond the man with the electrons on the pi electrons. Once the pi electrons are broken by the intermediate, then what happens? Already we have 4 hydrogen. Now these 2 hydrogen also will join with carbon and converting alkene into alkane. So ethylene becomes ethane, right? Alkene becomes alkane. So this is how nickel plays a very important role in breaking this bond and forming a new bond, then breaking the pi bond, and then finally making the product to be formed. So like that, we have number of reactions in which this catalytic activity is being seen, right? For example, we have the oxidation of sulfur dioxide. Sulfur dioxide gets oxidized in the presence of vanadium oxide as a catalyst to form sulfur trioxide. In this is the catalyst that is being used. Then we have the propene, right? Propene gets oxidized in the presence of catalyst like iridium and ruthenium in the presence of carbon monoxide, and it forms 2 aldehydes. It forms CH3, CH2, CH2, CH4, which is butanol, and it also forms CH3, CH3, CH, CH4. This is 2-methyl 2-propanol. This is the other product that is taking place. So for this ruthenium and iridium are used as the catalyst, right? And then we have Ziegler Nuttall catalyst. Right? So Ziegler Nuttall catalyst is the reaction in which CH3, CH double bond CH2 is undergoing polymerization with 2 substances, silicate tetrachloride and triethyl aluminum or titanium chloride, rather titanium tetrachloride with tetraethyl aluminum. This is called Ziegler Nuttall catalyst, which polymerizes this molecule and it forms polypropylene. This goes Einstein. This is called polypropylene. Right? So this is how the product that is being formed in this catalysis. Right? So like that, even there is a conversion of acetaldehyde to acetic acid. That is also possible with a catalyst. So these are some of the examples of the catalyst role in chemistry, right? So we should know, the only knowledge is that transition metals, due to the presence of the d electrons, are capable of acting as catalyst, right? And the other properties, we have 3 more properties which we'll take up tomorrow, right? Take care, God bless you.